Hello everyone, how are you today? Good evening. And so today I have done my um data mining final exam, and I really enjoyed it doing it. It was a challenging task, but thank God I completed it within the time. And let's turn towards our code. And first, like I'm gonna tell I have neither given nor received, nor have I tolerated others' use of unauthorized aid. And I did follow my honor code. And let's go towards the next step now. Okay, so my data was student performance in it is in student performance in Portuguese secondary schools. So it was related with the all the information for students, school information with the my camera is still okay with the internet, students who have internet and who don't have internet with the free time or study time. So let's go towards each code step by step by each questions up there. All right, so the first question is there a class attribute in your data set? If not, what class attribute should be there? For what political purpose would be someone interested in this class attribute? All right, let's go towards our code now, our file. So all right, first I uploaded my there's a light coming up here. Okay, so first I uploaded my packages, all of the packages which is required and which is needed uh, to run my file up here. Pandas, numpy, cbon, matplotlib, train test flip, and accuracy score, confusion matrix, classification report. Then I just uploaded my data here, and here we can see it's a GitHub link here. Okay, so here's our data. We can see here my data. And so part one answer is okay, there is no class attribute in our data set. The class attribute should be the average of G1, G2, and G3, which presents the grade, final grade of a student. This attribute should be a category of data type with grades A, B, C as categories. Grades greater than 90 should be marked as A, lesser than B marks, and greater than 70 B marks at B, and less than 70 marks C. With this final grade categorical attribute, anyone can easily define a model which can predict the grade of a student based on the attributes. So here we can see there's no class attribute in our data set for G1, G2, and G3. And next, jump towards our next question. Okay, so the next question is we have to list the minimum, mean, median, mode, Q1, Q3 for the free time and study time attributes belonging to students who have internet and who don't have internet at their home with the smaller standard deviation. What does mean and what does it tell you about the opportunities of those people in different populations? All right, let's go towards that one. So getting students with internet at home, here we go, is internet is equal to yes. And getting summary free time study time, so count is 498. Mean standard deviation, mean 25%, 50%, Q1, Q2, Q3, and max value here, minimum is here. So they're getting students without internet at home, internet is equal to no. And getting their summary, count, means, median, mode, summary, Q1, Q2, Q3, quartiles, and max min. So for the free time attribute, the standard deviation is lower for students with internet at home. Hence, students with internet at home get done with their studies more quickly and have more time to focus on extra activities, thus providing them with better academic opportunities. For the study time attribute, the standard deviation is lower students who don't have internet at home. Hence, students without internet speed spend more time studying, thus decreasing their efficiency. Okay, so let's go towards our part 3 now. So the for each of the groups above, make a scatter plot against the class attribute and describe in detail how much you got assigned attribute and correlated. So the first one we have to correlate with the G3 for the class attribute which is correlated. So what I have done here, uh, I got four scatter plots with the two each, like two for the having internet and two of them who don't have internet, to get a whole image of the data. So here we go. Scatterplot who have who are has free time with the internet, yes, at their home. And here it is. We can see there is no clear pattern between the two attributes, which point to the fact there is no considerable correlation between them. The correlation between them look negative, but they have a very small value. uh, so with the study time and having internet, we can see here there's a somewhat a clear pattern between two attributes, which points that there is somewhat correlation between them. The correlation between them looks positive, but with a slighter higher value than the above correlation. Okay, free time and no. So with this one is no internet at home and free time, and again here is no clear pattern between two attributes, which point to the fact that there is no considerable correlation between them. The correlation between them looks negative, but with a very small value. And again here's a study time with no internet at home with G3, and we can see there's a clearly visible pattern between two attributes, which point to the fact that there's a considerable correlation between them. The correlation between them looks positive, but with a considerably higher value than the above correlation. Okay, then we're gonna jump towards our part 4. So separate the dataset into 25% training data and 75% test data, then prepare the training data to run a neural network of one of the classifieds below. So here we go. And we investigate the confusion matrices. What do the results academic to population, does the classification report make sense or not? Okay, so here's a data set. We can see here displaying the data set, all of it, G1, G2, G3 at the end. So converted the G1, G2, converted the G3 into categorical, assigning the grades to them, A, B, C, according to 90% and more than 70% and less than 70%. Here we go. The grades are here. We can see at the end. And after that, I just have done the encoded with labels here. We can see here columns listed, dfschools.columns. So columns G3 for columns into transform. Here we can see school, age and sex. It was into other one, but I encoded them. Here it is. You can see here these ones. Oopsie. Here it is. You can see that one. So after that, students with the internet, yes, internet is equal to 1, and student without internet is equal to 0, and getting only the independent attributes x and the one and no. With x no column, the target attributes grades categorical attribute. So what I've done here, I divided the data set who have internet at home. Yes, over here these ones have, so I can get a better result for my future running students models. And this one is, this data is for the yes, like who have internet, and this data is for who don't have internet at home. So running models for students with internet. So splitting our data set, xtrain, xtest, from sql learn neutral import mlp classifier, running neural networks, fitting the data, mlp accuracy is 0.6898, and neural network confusion matrix is here. And here we can see is between the two of them. Okay, which is similar, like echo. We got a good predicted level here. And the random forest classifier, x and y train predicting values. Random forest accuracy is 0.796, and random forest confusion matrix, we can see here is 0 to 0.0012. And the blue one predicted level, so this one was the who's having internet at home, and this one is who don't have internet. Without internet at home, accuracy is 0.80701. And neural networks here. And we can see here the predicted neural confusion matrix is 0.011, 0.011. In between them, these are the wrong one here is so it means like we are going in a good direction. And what accuracy is little bit higher, we got 0.8422 4. And you can see here's random forest confusion matrix is 0. So yes, a classification based on students having access to internet makes sense. The models have higher accuracy for students without internet, thus making it clear that students having no access to internet have predictable grades. So on the other hand, students without internet have a more randomized behavior, thus indicating that there is not a very clear pattern in their grades according to their attributes. So let's move towards our uh, part 5. Using the test data set, you have just need to move the class attribute and two of the clustering algorithms below. Produce a plot of your choice of identity clusters, and we're gonna have to what we discovered. I'm gonna tell about that one here. Okay, so it's the elbow method here. Max k is equal to 10, and range 1k, seeds not the none seeds here, and max it is equal to 300, and n initial is equal to 100, random state 0. So here we have run the internet with g1 g2 and max k is equal to 10. So we got the three here, the optimal k, and so n cluster is equal to 3 if it a k means model to data set. Visualization of that one is here. The three clusters are here with the internet g1 and g2. We can see the three colors up here, different colors. And so we're going to import the db scan model now. Db scan cluster, and sklearn cluster, db scan from sklearn. So number of clusters in labor ignoring noise points. Then we're gonna go towards the visualization here. It got 18 clusters up here, and g1 g2 the test data here. So here we can see here internet g1 and g2 18 clusters, and here we can see. So both the clustering methods shows almost similar results. They are dense into two parts, indicating students with and without internet. So it also shows that students with internet tend to have better grades in G2 than students without internet. However, students without internet have better grade in G1. So there's no clear outcome in such clusters, and we can decide which group of students is better in academics than the other one. So here it is. Then we're gonna go for part 6. What kind of political decision could the US Secretary of the US Department of Education make on the basis of classification and your cluster analysis? So the Secretary of the US Department of Education could consider looking at my analysis to get an insight about the effects of internet on the academic results of students. He could discourage internet for secondary school students. In our case, internet improves the grades. He could launch campaigns encouraging parents to provide internet to their children in order to get better academic opportunities. Obviously, we get a lot of sources, a lot of information from the internet if we use it in a right way, in a right hand. So the question number 3 for the manager analysis. Explain what new insights your analysis is going to produce for a manager or a government official who has to make decisions based on your analysis. So my analysis could help a government official in taking decisions. So regarding secondary school education, the general population thinks that internet has a negative impact on the academic of secondary school student. My analysis clarifies that the effects of internet are grade of a student. However, there might be a downside. For example, with internet to access, a student mainly instantly look up his homework and get it done in no time without going through books and doing the grind. On the other hand, a student having no access to internet goes through course book and consults the instructor, thus getting a better grip over the concepts and learns more during the process. However, if the primary concern is the grades, the government official may ensure that internet is available to every secondary school, thus bringing them all an equal level. As a result, no student is disadvantaged when compared to others. This will only ensure fairness and equal opportunities for all the students. In order to provide internet to the children, he may run campaigns or maybe signs contract with the ISPs to provide internet to students as discount. This could also lead to a change in thought process of general public about the perception of internet effects on academic life. And we also agree with that one. And that's my opinion, and I believe so it's right. And I really enjoyed this semester. I have learned a lot under the supervision of my professor. She is I'm really thankful to her. I'm really thankful to her. Professor, you are great and always stand up aside with us whenever we needed you, and your teachings are the best one. You're my best teacher, I can say. Thank you so much, and it was a great semester, and it was all from my side. Thank you.